Today I am going to deliver a lecture on Introduction of Welding. This is the overview, or you can say content of this today's lecture. I will cover the following topics like syllabus of the course, definition of welding, history of welding, common welding base material, general advantage of welding, general disadvantage of welding, welding as compared to casting, like other manufacturing process which is comparable with welding, like casting, and welding as compared to riveting and its practical application in details. First of all, I will cover the syllabus of the course. This is the week wise module name, content to be covered, and number of lecture planned is given. In first week, I will cover the module whose name is Introduction and Classification of Welding. Here I will cover introduction of welding, classification of welding processes, type of welding joints, type of edge preparation. It will take 2 lectures. Now, in second week, the module name is Nomenclature and Symbol of Welding Joint. Here I will cover welding joint design, different types of nomenclature of welding joints, welding symbols. It will take around 2 to 3 lectures. In the third week, I will cover power source of welding. Here I will cover type of power source and their characteristics. It will take around 2 lectures. In the fourth week, I will cover physics and principle involved in arc welding process. Here I will cover welding heat sources, arc initiation, type of arc, then forces affecting the arc and metal transfer, then arc blow. It will take around 3 lectures. Then in fifth week, I will cover different types of welding method and their details. These different types of welding method and their details will take another 2 weeks also. Like in 6 and 7 week also, I will give lecture on different types of welding method and their details. Like in fifth week, the different types of welding method and their details are waxy fuel gas welding, shielded manual metal arc welding, then gas tungsten arc welding process. Then in sixth week, I will cover different types of welding method and their details like gas metal arc welding, submerged arc welding, then electrocyclic welding. Then in 7th week, different types of welding method and their details I will cover electro gas welding, resistance spot welding, friction welding, and plasma arc welding. These are the different welding processes which I will cover in this 3 week, which are generally widely used in traditional manufacturing industry. In week 8, I will cover welding defects and their inspection. Here I will cover different types of welding defect, destructive and non-destructive testing. This will take around another 2 lectures. This way it will take around 20 to 24 lectures. These are the reference or textbooks which I will follow for this course, like Welding Technology and Design by V.M. Radhakrishnan, then Computational Weld Mechanics by J. Golduck, Metallurgical Modeling of Welding by O. Grung, Computational Weld Mechanics L. E. Lindgren, Dr. O. P. Khanna's book like Welding Technology. Apart from this, I will follow Welding Handbook, then the Physics of Welding by J. F. Lancaster, then Principle of Welding like R. W. Messler. These are the following reference or textbook generally I will follow in this course. Now, the definition of welding, what we can say that the definition of welding we can say in general, it is a process of joining 2 material plates and makes an integrated one. The material which generally is weldable are metal and their alloy. The welding is sometimes applied some other types of material like thermoplastic. Actually, thermoplastic is a material which generally during heating it's melt and during cooling it's solidified. That means during heating it's plasticize and during cooling it solidifies. So, this thermoplastic the example of thermoplastic is like PVC, that means acrylics, then nylon, different types of materials which can be weldable. in welding the heat is supplied either by electric arc or by gas torch or by some other means like mechanical means, it can be radiation energy means. Okay. The most essential requirement is heat, but in some process pressure is also employed. Now, in history of welding, here I will cover the history of traditional welding process, generally the conventional welding process which is widely used in industry. Like in Middle Age, blacksmith of the Middle Age welded various types of iron tools by hammering. The welding method remains more or less unchanged until the dawn of 19th century. Then in late 19th century, engineer and scientists apply advantages or advances of electricity to heat and join metal. In this time there was lot of famous researchers or scientists were there like Joule, Le Chatelier, etc. Then in early 20th century, prior to the First World War, welding was not trusted as a method to join different metal due to crack issue, because welding is such a process or such a technique where we are generally intentionally create a defect in a structure, because whenever we will do welding in a structure, then there will come some metallurgical then structural changes. So, due to this it creates different types of defects in a structure. That is why prior to the First World War, general welding was not trusted as a method to join two metal due to these crack issues. Then in 1930 and 40, here generally in this time industrial welding gained acceptance and is used extensively in the war effort to build tanks, aircrafts, ships, etc. The use of welding in today's technology is very extensive. It is a remarkable rise since about 19th century. Then the year wise, the detailed invention of conventional welding process is given here. Like in 19th century, in this century lot of major welding techniques were developed. Like in year 1830, Englishman Edmund Davy discovered acetylene in 1830, and acetylene was soon after that acetylene was utilized by the welding industry. In year 1880, that means after 50 years of 1830, there is developed another welding techniques, that is generally that was developed by French scientist Auguste de Maritines in 1881. Auguste de Maritines succeeded in fusing lead plate by using the heat generated from an arc. So, soon after that application of electric arc in welding field gained significant interest, and lot of different arc welding technology were developed after 1880. 1890, during the year 1890, one of the most popular welding method was invented, that is carbon arc welding. In this time thermite welding was also invented in the year of 1893. Then in 20th century there was developed lot of electric arc welding techniques. Apart from electric arc welding techniques, here there was developed some other welding techniques also like solid state welding and resistance welding techniques also in this century developed. This is the most important century where lot of invention of welding was done. Generally in 1900 years, in the year of 1900, coated metal electrode was first introduced by Strominger. A coating helped the arc to mass more stable. So, this is a very important development of an electric field. So, a number of other welding processes were developed during this period also, that is seam welding, spot welding, flash butt welding and projection welding. These are all generally resistance types of welding techniques. This is solid state welding types. These are all solid state welding types. Then after 20 years, in 1991, after the First World War I, the American Welding Society was established by Comfort Avery Adams. The aim of this society was the advancement of welding processes. In 1920, automatic welding was first introduced which was invented by P.O. Nobel. In 1920, an early predecessor of GMAW, that means gas metal arc welding, was invented by P.O. Nobel of General Electric. Then in 1930, the New York Navy Yard developed stud welding. Stud welding was increasingly used for construction industry and also for shipbuilding industry. Then in the year 1940, gas tungsten arc welding was, then the gas tungsten arc welding was another significant milestone in the history of welding, which was developed in Batley Memorial Institute in 1948. Then in year 1960, in this time, there are several advancements in the welding industry was happened. Like in this time, electroslag welding, plasma arc welding were invented. Then in year 1990, Welding Institute, generally in this time, Welding Institute invented friction stir welding in 1991. It is a solid state joining process which utilizes frictional heat of a rotating tool and steering effect of tool probe for solid state joining. The use of welding in today's technology is very extensive. The growth of welding technology is faster than the general industrial growth. Then in common welding base material, that means the material which is weldable can be categorized into two different classes. One is ferrous and another one is non-ferrous material. Like in ferrous material, the finding day to day welding application are wrought iron, it can be cast iron, it can be carbon steel, then cast steel and stainless steel. We will see what is wrought iron and which is weldable actually, which wrought iron is weldable. Generally wrought iron which has a carbon content less than 0.035% and rest of the things is iron. In cast iron, generally here two major components are there, that is carbon and silicon. Here generally carbon content varying from 2.3 to 4.5% and silicon percentage varying from 0.5 to 3%. Then in case of carbon steel, this carbon steel can be categorized in three different categories. It can be low carbon steel, it can be medium carbon steel or it can be high carbon steel. Generally in low carbon steel, the carbon percentage varying from 0.05% to 0.3%. In medium carbon steel, carbon percentage varying from 0.3 to 0.59%, and for high carbon steel, the carbon percentage is varying from 0.6 to 1. These are the cast carbon steel which can be weldable, that means which is weldable. Then in case of cast steel, so there is a difference between carbon steel and cast steel. Like in cast steel, generally here the carbon content varying between 0.2 to 2.1% by weight, but here is some other alloying element are there like manganese, chromium, vanadium, tungsten. These are the different types of alloying element is there in cast steel. But in carbon steel, generally these are the things is not there. Now in stainless steel, which is weldable, generally stainless steel also weldable. Stainless steel is that material where generally more than 11.5% chromium are there. Due to this percentage of chromium, generally in stainless steel, they are developed a stain layer over the surface of the steel. Due to this, generally this stain layer protect from the corrosion and it increase the corrosion resistance of the material. Now in case of non-ferrous material, which generally finding day to day welding application are aluminum and its alloy, then copper and its alloy, magnesium and its alloy, then nickel and its alloy and zinc and its alloy. These are the generally non-ferrous materials which finds day to day welding application. That means these materials we can weld. Apart from these things, lot of other material also can be weldable, like refractory reactive material also can be weldable nowadays. Now these are the general advantage of welding process. Like a good weld is as strong as the base material. That means in case of welding we can get a strength which is comparable with base material. That means whatever the strength of base material is there, we can get almost similar strength in case of a welded joint. General welding equipment is not very costly. Generally whatever the traditional welding processes we are using in industry, that welding machine cost is comparatively not very costly. Portable welding equipment is also available. That means we can take welding machine or welding equipment from one place to another place very easily. Then welding permit considerable freedom in design. This welding is such a technique where we can get lot of freedom in design also. A large number of metal and alloy, both similar and dissimilar, can be joined by welding process. Welding can join workpiece by spot, as continuous pressure tight, end to end, and in a number of other configuration also. And finally, welding can be mechanized. That means we can do welding automatically. These are the general disadvantages of welding, traditional welding process, like welding gives out harmful radiation, fumes, spatter. Welding gives out harmful radiation, fumes and spatter. Welding result in residual stresses and distortion of workpiece. This is a very vital drawback of welding process. That means once we do the welding, generally there will be the residual stresses and distortion of the structure. This residual stress and distortion generally tremendously deteriorate the welding structure's life. So, these are the residual stress and distortion. This residual stress and distortion is unavoidable in case of welding process. Jig and fixtures are generally required to hold and position the part to be welded. In case of welding, generally a skilled worker or a skilled welder is must. Simply a non-skilled welder cannot be do welding proper way. So, a skilled welder is must to produce a good welding job. Welding heat produce metallurgical changes. That means once we do the welding, then there will be the metallurgical change in the structure. So, which generally break the continuity of a structure between base material and welding region. Due to this, generally what happens, there will come different types of changes as well as defects. The structure of the welding joint is not same as that of parent material, which is a defect or which is a disadvantage of welding process. A welding joint for many regions need a stress relief heat treatment. That means I have already told you welding is such a process generally where we are intentionally creating the defect in a structure, but due to lot of region we cannot avoid this technology, because welding we have to use in industrial application for many reasons, that I will explain later on. Now, here why welding is so important. Here we are discussing welding as compared to other joining or manufacturing process, like welding as compared to casting as well as welding as compared to riveting process also. First we will explain welding as compared to casting. Generally machine tool bed which were earlier cast are now fabricated using welding process. In many fields welding has replaced casting processes. Some of the reason for the same, that means replacement of casting process can be stated like, first is welding is more economical and is much faster process as compared to casting process. Fabricated mild steel structures are lighter as compared to cast on. Fabricated mild steel structure have more tensile strength and rigidity as compared to cast on. That means once we produce a structure by casting, the whatever the strength we will get in that structure, if you do the same structure by welding, there we can get more tensile strength and rigidity. Cost of pattern and storing which is a very essential part in casting, can be eliminated in case of welding process. Here in case of casting, more labor or more person are required, but in case of generally welding, fewer person is required to do the welding fabrication. A structural shape which is not easily obtainable with casting process, that can be produced by welding process without much difficulty. Welding design involves low cost and it is a very flexible also. That means welding is such a process where we can get lot of flexibility in design as well as in fabrication. Now, fabrication by welding save machining cost involved in the cast part. It has seen after casting, machining is required to get the desired surface finish or desired quality of a structure. But in case of welding, this machining cost we can reduce tremendously, or we can fully eliminate the machining part in case of welding. Now, we will go to welding as compared to riveting. Earlier time, bridges, sheaves and boiler which were previously riveted are now welded. That means, earlier time generally bridge, sheaves, boiler which were fabricated or manufactured by riveting, but nowadays that is replaced by welding process. The reason being these are, welding is more economical and is a much faster process as compared to riveting. Welding pressure vessel are more pressure tight as compared to riveted ones. Ratio between weight of the metal and inter weight of the structure is much lesser than the ratio between the weight of the rivet and inter weight of the structure. Cover plates, connecting angle, gasket plates, etc., which are needed in riveting construction, but this is not required in welding structure. So, we can eliminate cover plate, connecting angle, gasket plate in case of welding process. Member of such shape that present difficulty for riveting can be easily welded. Welding can be carried out at any point on a structure, but riveting always requires enough clearance to be done. A welding structure possesses a better finish and appearance than corresponding riveting structure. Layout for punching and drilling of hole is not required in welding. This is a very important aspect in case of welding process. This is very much essential in case of riveting process. Generally, once we put some holes in a structure, then these drilling holes in the plate or in a structure break the material continuity and weakens a riveted structure. Making changes in already cast or riveted structure is extremely difficult, if not impossible. On the other hand, a welding structure can be repaired without much difficulty. Welding can produce a 100% efficient joint, which is very difficult to make by riveting or casting process. Riveting high strength steel presents the problem of acquiring high strength steel rivet. Acquiring of high strength steel rivet is problematic. Now, we will go to practical application of welding process. Generally, there is lot of practical application of welding process. Here especially I will cover the practical application of traditional welding process. Welding has been employed in industry as a tool for regular fabrication as well as repair and maintenance work. In regular fabrication, it is generally used in automobiles, cars, aircrafts, refrigerators, ships, offshore structure, etc. In repair and maintenance work, we will get the application in joining of broken parts, rebuilding worn out component, etc. Here I will show you a few important application of welding process. It has lot of application. We have seen that welding has lot of application. Here we will show you a few important application in different industry. Like in aircraft construction, we will find the application in welded engine mount, turbine frame for jet engine, rocket motor, fuel tank, fitting, etc. In automobile construction also we get application like arc welded car wheels, frame side rails, automobile frame and brackets. Then we can get the application bridges in pier construction, then selection length, etc. In case of building also we get different types of application of welding like column base plate, trusses, erection of structure. In pressure vessel and tank also it has different application like clads and lined steel plate, clad and lined steel plates, shell construction, joining of nozzle to the shell, like in storage tank also oil, gas, water storage tank. In railroad equipment like rail, underframe, air receiver, engine, etc. Piping and pipelines like roller plate piping or rolled plate piping, open pipe joint, oil, gas and gasoline pipelines, etc. In shipbuilding industry like shell frame, deck and bulkhead stiffeners, girders to shell, etc. Truck and trailer also there is lot of application of welding process. Then machine tool frame, cutting tool and dies also it has lot of application. Household and office furnitures also it has lot of application. In addition to this industrial application or fabrication application, it has also different application in repairing and maintenance purpose also. In addition, arc welding finds following application in repair and maintenance work, like repair of broken and damaged component and machinery such as tools, punches, dies, gears, press and machine tool frame. Fabrication of jigs, fixtures, clamps and other work holding device also done by welding process. Now, here is a very important aspects of welding application in hospital building, especially in hospital building, like being noiseless as compared to riveting. Welding find extensive use when making modification, addition or extension in hospital building. Now, classification of welding process. First of all, joining process classification I will explain. After that, we will go to classification of different welding processes. Generally, joining process are basically classified into two different types, which can be mechanical bonding or atomic bonding. Generally, mechanical bonding in these categories, this mechanical bonding further categorized into two different categories. One is temporary and permanent or semi-permanent categories. In temporary category, we will get screw element, and permanent or semi-permanent joining process can be rivets, it can be stitches, it can be staples, it can be shrink fit. And in the categories of atomic bonding, generally welding is the main categories. Now, classification of welding can be done based on the following different aspects. Here I am showing that 6 major aspects generally followed for welding classification, which generally welding we can classify depending upon the source of heat, it can be depending upon the application of pressure, it can be depending upon the different phases of base and flare material, it can be depending upon the composition of joint, it can be depending upon the position of electrode, and finally it can be depending upon the mechanism. So, one by one of this classification I will describe in detail in next slides. First of all, depending upon the source of heat, that means which source we are using to do welding. Depending upon this source of heat, this welding process can be further categorized into another 6 different categories. This source of heat either can be arc from electric arc, it can be from gas reaction, it can be from resistance, it can be from thermochemical reaction. This heat also can be from mechanical energy, and this heat can be from radiant energy. So, depending upon this thing, generally this welding can be categorized like this. That means it can be arc welding process, it can be gas welding process, it can be resistance welding process, it can be thermochemical chemical welding process, it can be mechanical energy welding process, or it can be radiant energy welding process. So, different welding techniques name depending upon this is the most important. That means here generally I am showing different welding techniques name depending upon the source of heat. Like in arc welding, there is around 8 to 9 different categories of welding process are there, that I will tell. That means in arc welding there is around 8 to 9 different welding techniques is there. In gas welding there is another 4-5 different categories of welding process are there. In resistance welding, that means where the source of heat is resistance, here also we can get around 5-6 different categories of welding process. Then in thermochemical welding process, there we will get around 2-3 different kinds of welding process. In mechanical energy welding process also we can get around 5-6 different categories of welding process. And finally, radiant energy welding process also we can get 2-3 different types of welding process. Now, one by one I will tell in details, like based on source of heat from electric arc, it can be carbon arc welding. In short form, generally in short form it is written like CAW, that means carbon arc welding process. Generally this short form is widely applied in industry as well as in research article. This types of short form generally we can find. So, to see this short form itself, we should recognize what is the name of this welding process. Like in metal arc welding, this metal arc welding its short form is generally shielded manual metal arc welding, SMAW. It is represented like this. Then tungsten inert gas arc welding also is there. Its short form is generally TIG, that is tungsten inert gas, or it is more popularly used as GTAW, that is gas tungsten arc welding process. Similarly, metal inert gas arc welding process, it is also represented in short form like MIG or GMAW process. MIG means M for metal, I for inert, and G for gas welding process. Okay. Now, in GMAW it is like gas metal arc welding. This short form of these things, GMAW full form is gas metal arc welding process. Then plasma arc welding process, in short it is represented as PAW, that means plasma arc welding. Submerged arc welding is in short form it is represented as SAW, that means submerged arc welding process. Then electro slug welding process, it is represented as ESW. Electro gas welding generally it is represented at EGW. This should be G, electro gas welding. Generally in case of gas welding, that means where the source of heat is gas, this welding can be oxyacetylene welding process, it can be air acetylene welding process, it can be oxyhydrogen welding process, it can be pressure gas welding process. That means in case of oxyacetylene gas welding process, the heat is generated due to oxyacetylene gas reaction. Similarly, air acetylene, here heat is generated due to air acetylene reaction. Oxyhydrogen welding process, here generally heat is generated due to oxyhydrogen reaction. Then in resistance welding, there we will get different types of resistance welding where the heat is due to resistance heating. So, here generally we will get different types of welding process like butt welding, spot welding, seam welding, projection welding, percussion welding, flash butt welding. So, these are the welding process, generally these are all in the categories of a solid state welding process, especially in solid state welding process. Then in thermochemical welding process, there we can get thermite welding and atomic hydrogen welding. Then in mechanical energy welding process, there we will get frictional welding process, ultrasonic welding process, diffusion welding process, force welding process, roll welding process and explosive welding process. And the last category is that is radiant energy welding process. Generally this radiant energy welding process, we can get the energy from we can get heat from radiant energy. That is why this is called radiant energy welding process. It can be electron beam welding, whose short form is EBW, and it can be laser beam welding, that means laser LBW. This should be W. In next lecture, I will go in details about classification of welding and joints.